Hi, my name is Mr. D, and today I want to take a look at dividing fractions. So we have simplify the following expressions, and for the first example we're looking at 3/5 divided by 9/10. So the technique that we're going to use for both examples is called keep, change, flip. And the way it's going to work is we're going to keep the first fraction the same, then we're going to change the operation, and we're going to flip the second fraction. So when we simplify this, we could say that this is equal to, and we'll write it a little bit bigger, we keep 3/5, okay, and then we're going to change from division to multiplication, and then we flip the second fraction. So instead of 9/10, we're going to have 10/9. So at this step, there's a few ways we could finish this problem. One way would be to multiply 3 times 10 and write that as our numerator, 5 times 9, write that as our denominator. But it's much easier if you reduce before you multiply. So notice here that if we look at 10/5, even though they're not part of the same fraction, we could reduce this. 10 divided by 5 is 2. So we could cross off these two numbers here. 10 divided by 5 is 2, so we could replace this with a 2. And notice here, 3/9 reduces to 1/3. So think of 3/9, this reduces to 1/3 if we divide the numerator and denominator by 3. So that means that we could cross off and replace 9 with 3. So it's like we're dividing the numerator by 3 and the denominator by 3. We divided this numerator by 5 and this denominator by 5. So then we look at the numbers that are remaining, and this tells us that our final answer is equal to 2/3. Here like this. Okay? Since all we're left with is 2 in the numerator, 3 in the denominator, our final answer is 2/3. But if you did it the other way, you would get something like 3 times 10 is 30, over 5 times 9 is 45. If you reduce 30 over 45 by dividing the top and bottom by 15, you would also get 2/3. So you get the same answer either way, but it's much easier to reduce beforehand so that you're not multiplying with big numbers and reducing looking for factors such as 15. But for the second example, sometimes they're not going to write it with the division sign, but you have to know that the big fraction bar represents division. So once again, we're going to keep the fraction in the numerator. So we're keeping 6/7. We're changing this operation to multiplication. And now we're going to flip the fraction in the denominator. We're going to write it as 28/24. But this is a classic example of why we would rather reduce before we multiply. Because doing 6 times 28, that's going to be a big number. We don't want to work with big numbers. So we reduce beforehand. 28 divided by 7 is 4. And notice, 24 divided by 6 is 4. But if we think about 6/24, if we divide the numerator and denominator by 6, we're going to get 1/4. So this will simplify here like this. But notice 4/4 will also simplify. If we write equals 4 divided by 4, this tells us that our final answer to the second one is going to be 1. So our final answer to the second example is 1. But remember, the idea behind this is keep, change, flip. And now just really quick, why does this technique work? Well, think about the concept of common denominators. When you want common denominators, you multiply the denominator and numerator by the same number. But what's really going on here, even though it seems a little unorthodox, is you're multiplying the denominator by 28/24, which is the reciprocal or the flip of this fraction, but then you have to do the same thing to the numerator, 28/24. But notice in the denominator, 24/24 cancels, 28/28 cancels, which leaves you with that multiplication problem, 6/7 times 28/24, which gave us the answer of 1. So this is why keep, change, flip works. Just a little food for thought in case you're wondering why you're using this rule. Okay, well this is going to conclude this video on dividing fractions. Thank you all for watching, and I hope that this was helpful.